Hello, welcome back to the channel. So let's do one more question on volume calculation using definite integrals, and this would be a two-part video. First of all, in this video, we'll go over the first part of this question, and in the next video, we'll be covering the next three parts of this question in order to get the full idea and full understanding about this question in general. So in this question, you have been provided this information that the shape of the earth is often approximated by an oblate spheroid rather than a sphere. So the shape of the earth is not a sphere, it's an ellipsoid. So what it means by an oblate spheroid is formed by rotating an ellipse about its minor axis. So minor axis is the one which has the shortest diameter in this case. So you might also know in the case of ellipses that we have a minor axis and we have a major axis. The minor axis is the one with the shortest diameter. The major axis is the one which has the largest diameter, right? So based on the given information in this question, we have to find the volume of the oblate spheroid in this case obtained by rotating the upper half of the ellipse. So whatever ellipse we'll have to rotate the upper half of the ellipse, which means the part of the ellipse which is above the x-axis, and we have to rotate the upper part of this ellipse about the x-axis. So you have to rotate it about the x-axis. So you have the x-axis like this, right? So you rotate it about the x-axis where your a and b are positive constants with this given information, a greater than or equal to b, which will help you easily realize what the minor axis is and what the major axis is all about in this case. So first of all, in order to solve this question, we'll again follow the same steps that we followed in the last videos. So if you have not watched my previous videos, I will highly suggest you to first watch those videos in order to get the full context of what we will be doing in this video in order to solve this question by the steps that we talked about in the last video. So again, in order to solve this question, we'll first sketch the graph of this function, sketch this ellipse, and if we'll sketch this ellipse, we know that it's easier to sketch ellipses when we know about the intercepts. So we know about the basic shape of the ellipse, right? Once we know about the intercepts in this case, we will be easily able to sketch the graph of this ellipse in this case, right? So in order to calculate the intercepts in this case, we know that if we want the x-intercept, we'll substitute y equals 0 in this equation. If we want the y-intercept, we'll substitute x equals 0 in this equation, right? So let's calculate the y-intercept in this case. So y-intercept in this case would be substituting x equals 0. So it would be 0 square. I'm substituting x equals 0 in this equation. So it would be 0 square plus by whole square equals 1. So it would give me by whole square equals 1. By would be equal to plus minus 1. Y would be equal to plus minus 1 upon b, right? So the x-intercepts in this case are 0, 1 by b and 0, minus 1 by b in this case. And similarly, if we want to calculate the x-intercepts in this case, your x-intercepts would be, x-intercept is substituting y equals 0. So we know that if we substitute y equals 0 in this equation, we will get, similarly, we'll get ax to the whole square equals 1. So ax to the whole square equals 1. Similarly, ax equals plus minus 1, x equals plus minus 1 by a. So you got your x-intercepts as 1 by a comma 0 minus 1 by a comma 0, right? So now we have the intercepts, and now once we have the intercepts, we know how to sketch the ellipse, right? We know about the basic shape of the ellipse. So in this case, before sketching the graph of your ellipse, you will first identify your major and minor axis, and you have been provided in this equation, in this question, that your a is greater than or equal to b. So if your a is greater than or equal to b, 1 by a, I can write this as this, right? So you know that your a is greater than or equal to b, which means your 1 by a is less than or equal to 1 by b, right? So in this case, we know that this is an ellipse. So 1 by a would be less than 1 by b, and if 1 by a is less than b, which would mean that our minor axis is the x-axis and the major axis is the y-axis in this case, right? Feel free to comment down if you still have any doubts in this part. The basic overview is, since we know that a is greater than or equal to b, we derived this, which was 1 by a less than equal to 1 by b. And since we have 1 by a comma 0 on the x-axis and 0 comma 1 by b on the y-axis, so we know that the distance, since 1 by b is greater than 1 by a, we know that the distance of the ellipse from the origin to the uppermost y point is greater than the distance from the origin to the rightmost x point, right? So based on this given information, we know that the distance from the origin to the rightmost x point on the ellipse is smaller than the distance from the origin to the uppermost y point. So this gives us an indication that the x-axis would be our minor axis and the y-axis would be our major axis in this case of the ellipse, right? So now based on all the given information, we'll sketch the graph of our ellipse, and you already calculated the intercepts, right? Your x-intercepts were minus 1 by a and 1 by a, and your y-intercept in this case is also denoted in the figure. And you can clearly see that this is your minor axis, since your 1 by a is less than 1 by b. So that is why this is your minor axis and this is your major axis in this case, right? And now we have to, in order to calculate the volume, we have been told in the question that we have to rotate the upper half of this ellipse about the x-axis in this case. So now we have to take an aerial strip in this case, and you'll clearly realize that when you'll rotate this ellipse about the x-axis, you are basically building a circle, right? So if I take this example, if you are rotating this, you are basically, let's take a vertical strip over here, and imagine you are rotating this vertical strip about this line, and if you're rotating this vertical strip about this line, you are basically forming a circle, right? If I rotate this one, I'm basically forming a circle over here with the radius of this. And similarly, if I take a vertical strip over here and rotate this vertical strip about the x-axis, I'm basically making one more circle over here. So that is why when I'm rotating the upper half of the ellipse with respect to the x-axis, I'm basically building circles stacked to the right of each other, right? So what I'm doing this in this rotation is, when I'm rotating the upper half of my ellipse, I'm basically building circles in this case. So I'm basically building circles and stacking them onto the right of each other. So that is why, in order to calculate the volume, we'll consider our aerial strip to be the circle in this case, and then we'll calculate the area of our circular strip with the radius given. We know that the radius would be this one, which is easily the y value in this case. So based on the radius, we'll calculate the area of our aerial strip, and then we know that since we are making circles from left all over to the right end point, we will integrate our aerial strip from x equals minus 1 by a to x equals 1 by a in this case. Also, I know this is hard to get why we are building circles in this case, but if you will clearly visualize the rotation of the ellipse in this case, you will see that you are basically building circles which are stacked onto the sides of each other, right? Feel free to comment down if you still have any questions or any doubts regarding this part, but this was the basic idea about the volume calculation using definite integrals in this question. So now we know that if you're building our aerial strip is the circle in this case. So this would be the arbitrary circle, right? It would have the same radius below the minor axis, right? Since this is a circle, and we know that the area of this circle is basically pi times r square. So let's calculate the area in this case. We know that the area of our arbitrary circular strip is pi times r square. So in this case, we know that the radius is again the upper y value minus the lower y value. The upper y value is based on the elliptical function, and the lower y value is basically y equals 0, right? And the upper y value, since it is based on the elliptical equation, we can change this equation in terms of y equals fx, and if you'll change this equation in terms of y equals fx, you'll get y as 1 by b times square root 1 minus ax to the whole square. So similarly, if we have to calculate the area of an arbitrary circular strip in this case, it would simply be pi times 1 by b under root 1 minus ax to the whole square and square in this case. So again, simplifying it down, it would become area equals pi by b square times 1 minus ax to the whole square, right? So now we have the area, we just have to calculate the volume in this case, right? And the volume, we know that it is basically integral a dx. So our a in this case is the same thing, pi by b square, 1 minus ax to the whole square with a dx. We also know about the endpoints as we already discussed it in the first half of the video. So since we are building circles from the left endpoint all the way to the right endpoint, we will have our lower x value. The lower endpoint would be x equals minus 1 by a. The upper endpoint would be x equals 1 by a in this case, right? So this would be from x equals minus 1 by a to x equals 1 by a in this case. And this would be your final definite integral in this case. If you'll integrate this definite integral, you'll get the volume formed by rotating the upper half of the ellipse about the x-axis in this case. So about the x-axis in this case. So again, I'll leave the definite integral calculation for you, and I would highly appreciate if you can comment down the answer to this definite integral in the comment section below. That would be a good practice for you as well. And once you'll calculate this definite integral, you'll get the volume of your required region in this case. So that's it for this video. Feel free to comment down in this video if you have any doubts or questions related to this question. And also, since this was the first part of this question, we'll also go over the next parts of this question, which will also give you a better idea about this type of questions being asked in your midterms and final exams. So follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.